Okay, we will learn about radiochemistry. Okay, the definition of radiochemistry, the study of chemistry of atom which have radioactive nuclei. Okay, this is the example of radioactive nuclei. The upper part is for the mass number and the lower part is the atomic number. When the atomic number is same, we can call it isotope.
There is three types of radioactive decay. Okay, the first one is alpha particle, beta particle, gamma ray. The first is symbol. This is the symbol for alpha particle, and this is the symbol for beta particle, and this is for gamma ray. The second one is mass. For alpha particle, it is 4. Beta particle, it is 1/2000, and for gamma ray, it is 0. Then charge. Alpha particle is +2, beta particle is -1, and gamma ray is 0. Next is speed. For alpha particle, there is slow, beta particle is fast, speed for gamma ray is very fast. For penetration power, for alpha particle is low, for beta particle is medium, and gamma ray is high. And it can stop by, for alpha particle it is paper, beta particle is aluminium, and for gamma ray it is lead. This is the illustration for penetration power of radiation. For alpha particle, it can pass through and can be stopped by tissue. Then for beta particle, it can pass through tissue, but it will be stopped by aluminium. Then for gamma ray, it can pass through tissue, can pass through aluminium, can pass through for concrete wall, but can stop by lead.
For decay, alpha decay is a type of radioactive decay in which an atomic nucleus emits an alpha particle. This is the example of alpha decay. When plutonium decay, it will release uranium and alpha particle. How does beta decay occur? Sometimes an atom will emit a beta particle when break up. This is the example. In beta decay, a neutron apparently spit out an electron, beta particle, and become a proton.
This is the periodic table of the element that we use to balance nuclear equation. The first law of the nuclear equation is the law of conservation of mass number that stated the sum of mass number on the reactant side must be equal to the sum of the mass number on the product side. Then the second law is the law of conservation of charge that stated the sum of the atomic number on the reactant side must be equal to the sum of the atomic number on the product side.
Of decay of radioactivity, we found that the radioactivity of gas decayed with time. In the case of radon, the decay curve is shown as below. This is the curve of radon. The decay of radon separate from radium. B. Growth of radon in an initially pure sample of radium. The activity decreased in such a way that it reached 1/2 of its value after 3.8 days. Thus, after 3.8 days, it was 50% of its initial value. After 7.6 days, 25%, and so on. All known radioactive species have been found to decay in these manners. Half-life. Time required for a radioactive atom to reach 1/2 of its initial activity. This quantity is the characteristic of the particular radioactive substance. Level of radioactivity of an isotope is inversely proportional to its half-life. The shorter the half-life, more unstable nucleus. Half-life of n radionuclei is constant. Rate of disintegration is independent of temperature or number of radioactive nuclei.
The diagram that show how half-life works. For inertia, parent isotope is 100%. When first half-life, parent isotope is 50%. When second half-life, parent isotope is become 25%.